Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us move to another question. Question number 9 on gravitation. Friends, let us start with the next question, number 9. It says that a solid sphere of lead a spherical hollow is dug out from it. As you can see from here, this is the figure. It's a sphere whose radius is r, and a spherical whose radius is equal to r by 2. Portion which is dug like this is a sphere which is dug like that. This is center of this sphere is r by 2 from here. The radius is r by 2. This radius is r. This total mass is m. This much portion, this is the removed part. Portion. So this is the sphere which is dug out from a given sphere of mass m and radius r. Now, such a way that its boundary is touching the center of the sphere and the edge here. Okay. You have to find the gravitational force acting on a point mass which is placed here, point mass m, and point P, which is at the distance of r from O. From here, this distance is r. So at a distance r from the center of the sphere, the point mass is placed, and how much force will act on this one, that you have to find. This is what is the question. So the question is not about the whole sphere and the point mass. It is about the whole sphere and some part of this is removed. The remaining part, what is left, that part, how much force will exert on this particular mass m. I'll write, just complete the sentence. Find the force on m, small as m, placed at a distance r from center of bigger sphere along the radius. Now the solution to the question. When I have a whole mass and I have some portion is removed here, this much is removed, this much is left. Now this one is having radius r and this one is having radius r over 2. Okay, this point is placed here, P, and the distance from here to here is r. Now the thing is that the force on this one, because the whole mass and because of this mass that are minus, because the whole mass the force is supposed that it is F1, and because smaller mass the force is supposed F2. And if I consider that to negative mass, then that F2 will be in this direction, and this F1 is in this direction. The total forces that will add up will give me the force acting due to the remaining portion. So the remaining portion, actually this original mass plus the removed part, this is, I will consider mass as negative mass, then I'll just add up, I'll get the same result. So because of the bigger mass, the object is lying, point is lying at a distance r, and the force will be G m over r square. Because it is smaller mass sphere, the force will be minus, because the minus there, mass is my negative I've taken, G m dash m over this distance from r by 2 is removed, so r minus r by 2 the whole square. Okay, now the net force acting on this particle F net equals to G mm over r square minus G m dash m over r minus r by 2 the whole square. Now we have to write this m dash, the removed part portion mass is m dash and radius is r by 2. How much is the mass corresponding to this portion in terms of capital M? Because the sphere is uniform, so I'll write that this mass and this volume is 4 over 3 pi r cube. R cube means r cube by 8. That is equal to the total mass m, and the total volume is 4 by 3 pi r cube, because the radius r for a bigger one. This 4 by 3 pi r cube and this 4 by 3 pi r will cancel out. This 8 will go up, so it is 8 m dash equals to m. So m dash is m over 8. This is clear? M dash is m over 8. So I'll put here. So I'll get this is G. This part will remain the same, minus this m dash part is m over 8. I'll substitute m over 8. M is already there, divided by r minus r by 2 the whole square. Now if I solve that, then I'll get GMM. I'll take a common. This is 8. I'll take okay, this is 1 over r square minus 1 over 8 r minus r by 2 the whole square. This is the net force that is acting. You can solve it further. There's no doubt about that. You can solve further to get some result. I'll just say that this is the answer. You can take r square common out, no problem, but this is the answer to this question. So this is the force that this particle experiences. Okay, thank you.